All right, let's talk about section 7.5, in which we solve polynomial inequalities. So, an inequality, we can write some notes here. If it's greater than or equal to 0, we're looking for where the regions are positive. If it's less than or equal, then we look for where the regions are negative. So less than or equal to 0 here. If we find two solutions, we should expect to be able to test 3 regions. If it's an x cubed and we find 3 solutions, then there will be 4 regions where we consider are these regions positive or negative. So these should be factorable. This is a difference of squares. We take the square root of both terms. They're perfect squares. So what would these zeros be? Where would we hit the x-axis? We set each factor equal to 0 to figure out what the zeros would be. And these are easy to solve. And these come in pairs, so here we get negative 2/3. Subtract the 2, divide the 3. Whatever your perfect square binomials look like. Now, I solved this with the positive on the left and the negative on the right. But don't make the mistake of getting your turning points or your zeros. Don't make the mistake of getting these out of order. So, a few ways that we can do this test. What are the values that we can test? We're thinking about the x-axis like a number line. If you can test 0, you should always test 0 because that's easy. Something to the left of negative 2/3 would be, negative 1 right here. Anything to the right of 2/3, we could use positive 1 as a test point. But again, it's any value in this region. I could have used positive 10. I could have used negative 5 over here. So what does it mean to test these regions? Well, consider the factors. 3w minus 2 times 3w plus 2. And we only care, do we get a positive or negative value? Because here we are set greater than or equal to 0. So we want to know where the function is positive. So what if we plug in negative 1? 3 times negative 1 minus 2. That gives us negative 3 here, minus 2, which is negative 5, times 3 times negative 1 plus 2. I added too many parentheses. We get negative 3 plus 2, which is negative 1. We're multiplying these here. So if we multiplied negative 5 times negative 1, because this is where we are testing the region of negative 1, the region to the left of negative 2/3, A negative times a negative is positive 5. In this case, negative 5 times negative 1. But again, all we care about is that our value is positive. So we are positive right there. Any negative value that we plugged in would have yielded a positive value. 0 is easy to test. If I plugged in zeros into our W, the W term would just zero out. 3 times 0 minus 2 is just negative 2. If we zero out this W, we get just a positive 2. Again, we're multiplying our factors. So negative 2 times positive 2 is a negative 4. Again, the only thing we really care about is that it's negative. And finally, we test the region to the right of 2/3. So again, we're negative right here, not positive. So if I test positive 1, that's 3 times 1 minus 2 times 3 times positive 1 plus 2. Here we get 3 minus 2, which is positive 1, or just consider that it's positive. Here we have 3 times 1 plus 2, which is 5. But again, just consider that it is positive. Because we only need to know, is the region positive or negative? And a positive times a positive is a positive. So we found two solutions. If we graphed this, it would be a parabola hitting the x-axis at negative 2/3 and positive 2/3. So what does our answer look like? Of course, if we have lines under the symbol, we use brackets. No lines under the symbol, we use parentheses. Once we get to the rational inequalities, we have to consider that the denominator can never be 0. But here, for this question, we're looking for where the function is positive. It's positive from, the number line goes on towards negative infinity and positive infinity. So our answer is that we are positive from negative infinity to negative 2/3 with a bracket unioned with positive 2/3 to infinity. The infinities always get parentheses, but these are the regions from negative infinity to 2/3, negative 2/3. And then pick back up again above the x-axis from 2/3 to infinity. So let's look at one more because these take a little bit of time. I'll show you how to use the calculator. Let's take a look at something like number 3 from 7.5. W squared is greater than or equal to 5W. For number 2, if you need help with that, I'll make another video on it, but you just have to distribute what's on the right, then get everything on the left side and factor, find your two solutions. And like this one, if we're not set n equal to 0, we have to move this piece over. You're not really going to have to swap your signs in these problems. You just have to move everything on one side, well, to the left. So again, we're looking for where the function is positive. We can factor out a w. So these are the two factors. If it's just if it's a binomial, then you add or subtract. So here we get 5. But here we just set it equal to 0. If you had a coefficient, it would still just be 0. So let's talk about this in the calculator. Try to get us in a good spot here. We have, once everything is on one side, we use the variable x. So w squared minus 5w is x squared minus 5x. Let us look at the graph. It's good to find these solutions on paper here, but we can see that we hit the x-axis at 0 and 5. I like to use the trace button. I hit trace, I type 0, I hit enter. If I see that y is equal to 0, I know that I found a solution. I can hit trace and hit 5 and hit enter. Again, I see that y is 0. Perhaps you verify this in the table. We can see that. But I like trace just in case we get a solution with a radical or a weird fraction. We can type in specific values into trace. So again, we're asked, where is the function positive? And we can look at the image here. If it's a quadratic, just a squared variable, I think it's nice to just look at the image. Once you know what the zeros are, it's just where is it positive. If it's asking where it's positive, it will be these two regions on the outside. So here we have negative infinity to 0 unioned with 5 to infinity. Let's pretend that we were asked to find w squared minus 5w is less than 0. Let me move this down. So now we are asking, where is the function negative? And if we're asked where is the function negative, that's just the region that dips below the x-axis. So if it's asking where is it less than 0, this would be, without a line under the symbol, just 0 to 5. So that's how inequalities work with quadratics. It's nice to just put it in y equals, look at the graph. Here you could have just gone to the table and found the zeros, but this is easy to solve. So I'll end this video and I'll make another one for, I'll do problems 2 and 5 on the next one.